Hi everyone, welcome back. The next video on sine, we've done cosine rule and finding the length of the side and finding the angles. Now we've done the sine rule, finding the length of the side. Now it's finding the size of the angles. Let's go through it as if there's no complications and everything's easy. So let's have a look at it. If you're a letter person, you'd write it as, here is a capital A. That makes this one over here a little a. So across from the capital A is the little a. Here is the capital B. So across from the capital B is the little b. So let's go to the rule. A on sine A equals B on sine B. And some people like to write C on sine C. Or you can write different letters altogether. Doesn't matter what the letters are, as long as, if you look at what's happening, that's a pair. So for each capital, there's its equivalent little letter straight across from it. So for this capital, there's an equivalent little letter straight across from it. Again, I call it two pairs. It's not three lots of information around the outside, it's two pairs. So we're only using those two opposite sets. Let's have a look what it becomes. Little a becomes a 7, capital A is a 35, don't forget to write the word sine. Little b is a 10, capital B this time is this thing which we refer to as theta. Theta. It's actually the Greek letter theta. So for some reason the whole world years ago, or most of the world years ago, decided that we're going to use Greek letters when we're talking about angles. Which was nice, it makes them stand out more and different to when we're using algebra with x, y, and z and a, b and c. So this one becomes a sine of theta. Now here's where people come unstuck, is solving this. There's all sorts of things that people can do wrong. I'm going to treat it at first at this stage as if you had a scientific calculator, or if you were able to do it without a calculator and figure out what the answer was. So let's have a look what the possibilities are. There are so many on this, I could talk about the different possibilities. If you had a class pad calculator like we do in WA, you could go solve and it'll give you the answer, and we'll talk about those answers in a moment. There's two possibilities. One I do tend to often come back to is this one here called cross multiply. And a lot of people, when they get to this level of maths, will see cross multiplication over and over again. I put a big X there, I think my teacher even did back at school, to remind me that I'm going to go that 7, that numerator, multiplied by the other denominator. So that's 7 sine theta, not teaching it at length. This is not, I normally talk about opposites to both sides. This is called cross multiplication. So cross, or just cross multiply. There's various uses of the word cross multiply. This is one of them. That times that equals that times that. So numerator by the denominator equals the numerator by the denominator, or whatever order you want to do, as long as it's the two other pairs. So here we have it. We've got a 10 sine 35 degrees. Now is when I talk about the opposites of both sides. Between the 7 and the sine is a multiply. How do I get rid of a multiply by 7? I divide by 7. If I do it to the left-hand side, I've said that so many times, I do it to the right-hand side. So basically, you come down with this situation here of sine theta equals 10 sine 35 degrees on 7. Remember, this is stored in the calculator. As long as you check you've got your calculator set on degrees, it's stored under degrees, it's stored under radians, and it's stored under grads, depending on which one of the three systems you use. So please check your calculator set on degrees. And you have to figure out how to do this. I'm going to say at this stage, there's so many ways I could say this, but I want to change that into a decimal, and I've written it down here what it is. So if you picked up your scientific calculator, just go 10 times sine 35 divided by 7, and your calculator will tell you that it's 0.81939, and you can get more decimals, but that's plenty of decimals for that. Then, to go from there, back to getting the angle itself, here's where people get mucked up. Most calculators have a shift. You go shift and press the sine button, or you'd have a second function depending on your calculator and press the sine button. If you're on the class pad, you go press the sine button with a little -1 on it, which is in the keyboard. So you're looking at the keyboard under Trig, and you'll find that one in there, and they'll give you the answer to it. The reason why, oh, by the way, the angle turns out to be 55 degrees. Now, let's have a look at the triangle I've got up here. There's no way in the world that that's going to be 55 degrees if this was a realistic diagram, and I can tell you now it is a realistic diagram. So this is where the problem comes when we're doing the sine rule. It's what we call the ambiguous case. All it means is that when you're finding the angle on a sine triangle, there's two possibilities. And we can explain this at length. You can watch other YouTube videos that go to length. You might notice I try to keep things simple. If I drew another line that come down there like that, and I come across here like this, there's our 10, there's the same 35, here's the 7 there, but instead of the 7 there, it becomes the 7 here. So we have two sets of circumstances or two sets of triangles that could achieve the same information. So on this one, the angle comes over here to be sine theta there, and here's a simple rule. If this one turns out to be 55, this one will be subtracted from 180. So if this one is 55 degrees, this one subtracted from 180 will be 135 degrees, 125 degrees. So 55 and 125. There is so much I can tell you about that and how to do it on your scientific calculator, how to do it on your class pad. ClassPad's wonderful because you can say, I only want the answer between 90 or I only want the answer between 90 and 180. That's for another video. It becomes too long here. That's about the ClassPad. There's plenty of videos on that. This is just about what can I get? When I'm getting the angle, finding a sine rule, I can get two answers. Your teacher might say, please give the two answers, and your calculator gives you 125, and you go, well, the other one has to be 55. Or your calculator gives you 55, and you go, 125. If I had 30 people in front of me and they've been using their scientific calculators all the time, some people will get the 55 and some people will get 125. And it's not just random. What it works on is, for example, let's say the last time you were using your calculator, you had an answer like 200. So it'll start at 200 and it'll say which of those answers is closer to 200, and you would get the 125 answer, even though your previous answer wasn't even Trig. This one here, so if someone had an answer previously of 10, then it would go to that answer. So it's purely random. So all I like to say to people is, once you get one answer, to get the other answer, make it, subtract it from 180. Now, there are times when the teacher will give you a triangle that they actually want drawn reasonably and they'll want that answer and that answer only. So if your calculator told you 55, you then have to say, no, it's not 55 because that looks unreasonable. You could even draw a fairly reasonable diagram to scale yourself and say, no, it's 100. Okay, if you're using your class pad, you can go solve for this sine theta equals 10 sine 35 degrees on 7. You can just type that straight in and say, give me the answer. And when you press XE, it will give you a complicated answer. But in the complicated answer, which talks about constants, you'll have two numbers. One will be 55 and the other will be 125. It might be, 55.01 or something. It doesn't have to be whole numbers. I just happen to pick some nice numbers for this one. And it'll give you a whole series of answers. If you want to know the shortcut to save that happening, when you do the solve, you can say, I only want the answers. This is in Math 3, between 0 and, for example, say you wanted it between 0 and 90 degrees, but you have to use these symbols here. And then you have to say, I'm looking for theta, and you put the theta there. If you wanted to, instead of writing theta, it's okay if you just call it x. The good part is the calculator defaults to the x button. So instead of saying constant and all this other information that's there, most people I've found over here don't bother with that. All people do is they just go solve, look at the two answers, and you can see where they are. And if it's a scientific calculator, it won't give you the two answers, it'll only give you the one, and you have to subtract it from 180. I hope it helps.